Reminder, we are recording this, and Andrew has 50 minutes plus 10 for a Q&A session. Andrew, please.
All right, thank you. Thanks for inviting me and being flexible. I had some weird time constraints, so happy we were able to make this work out. Yeah, so I'm going to be presenting some joint work with May Hassan at MIT, and then it looks like May is actually here.
Yeah,
great. And Tak-Huen Chau, who is a student of mine at Berkeley. Now that May's here, she can like fact check me on the backstory of this paper, which is that back in 2016 I published a theoretical paper which argued, I won't go into any of the details, that when you think about how communication technology like social media affects protest, that's more likely to be through the channel of helping protesters kind of solve what I call a more mundane tactical coordination problem of just trying to figure out when and where and how are we going to protest, rather than the mechanism where social media might help people air their grievances against the government. And so again, this is just like, for purely theoretical reasons, it just seemed like this coordination problem was easier to solve with social media. And so then, like May reached out to me after she'd been in Sudan during this uprising in 2018, 2019, and she sort of said to me that like my paper was helpful and sort of half right, but also half wrong. And so the part that she said was half right was that this focus on this tactical coordination, that it's more about, again, the mundane planning of when, where, and how to protest than it is about complaining about the regime. That seemed consistent with what she was seeing on the ground. But on the other hand, that paper also missed a key dynamic, which is that in addition to helping connect protesters so they can communicate this kind of information, this new technology can also help the government be able to monitor and repress these activities. And so what she saw was that these protesters were spending a ton of time and effort trying to keep the information away from the government, and that dynamic kind of wasn't present. And so really the goal of this was to try and come up with a model that would kind of capture both these dynamics, that would sort of retain what seemed right about the previous paper while also capturing how the government is using these technologies. Here's a picture of maybe what we might think about communication that could help tactical coordination. This is what we might call a protest calendar. So I don't read Arabic, but I believe the green things on the side here are essentially saying these. I think these are different dates. And then over here, we have kind of different protest activities that are going to happen on those dates. Right? So sort of laying out on this date, this is when and where there's going to be a certain kind of protest. So other co-authors, so Tak-Huen was also on the ground in the protests in Hong Kong around the same time, a little bit later. And kind of strikingly, you see something very similar here, where now hopefully we can all read this, that we have on the time and date, here's where people are going to be protesting, maybe in what they're going to be protesting about. So these if you just put this stuff out publicly, that's going to be very helpful for other protesters. It's also going to tip off the government, who can then know what they should do if they want to go and try and stop these activities from happening. So another technology that you might try and use to make this more hidden would be to use another social media app, which if anyone wants to chime in, they can like get a prize for saying what social media app this is. Or if people are going to be shy, they don't have to.
Tinder.
Yes, so Tinder. So this is a dating app where presumably there's maybe going to be more people interested in protesting than kind of like police trawling it for information. And so this is actually, I think, a slice from that previous calendar saying, hey, here's where certain protest is going to be. Potentially, this is a way to get the information into the hands of people who you want to know about the protest, but not the government. So obviously with social media, there's a wide range of technologies that protesters can try to use to communicate. So just to pick some that were used in this Sudan example, you can think about some relatively public options like posting something in a public Facebook group, posting things on Twitter. Graffiti was a very important analog source in Sudan. And then on the other extreme, there's more sort of private options, which are going to be much less visible. It's going to be harder to get information to people who aren't already in your network. But if you have like a small WhatsApp group of movement organizers, you can if you want to be secretive, you can just sort of stick flyers under people's doors who you are confident are not going to turn you into the police. And so again, the broad point is that there's sort of so much effort being put into keeping this information away from the government, and it sort of didn't seem like a lot of the related models were capturing this dynamic. So I think there is a common acceptance in the literature on social media and political action or on protest that technology has this dual effect where it can both help connect citizens to each other, but it can also help the government monitor and repress protest activity. I think just as a quick broad brush, it's probably fair to say that most work, empirical or theoretical, focuses on one side of this or the other. So sort of a lot of work that studies just how like citizens are using this technology to communicate with each other. Similarly, there's like another wave of literature that looks at how the government is using this technology. But kind of the angle we want to take here is that we want to have a model where, in a sense, we accept both sides of that equation. So in some sense, if you only look at the protesters and ignore the government, why is the government allowing this technology to be used? On the flip side, if you only look at the government side, then why would the citizens be using this technology if they knew it was just going to give away to the government what they're doing and help the government stop their movement? So in a sense, we kind of want the agency of both actors to be respected, and we want to understand why, in a sense, like both sides might use the same technology. So there's sort of a big modeling tradition, including my previous paper, that focuses on information and coordination and sort of protests, other kinds of collective action, sort of a million citations we can put in there. We're actually going to start in this particular model from a different tradition, which is a little bit older, not quite as prominent recently, but what I believe Tukey actually coined this phrase of what are called kernel blotto games. So these are games where there's typically one actor who's kind of trying to avoid another actor. And so the particular class of models we're going to build on was some work by my late colleague Bob Powell, who had these a couple of wonderful papers about sort of non-zero-sum continuous choice games with this feature. So we're going to have one actor who's kind of allocating resources to defend sites and another actor who's deciding what sites to attack. And so essentially, really just like what we're going to do in this paper is we're going to take that model and add a coordination aspect. And we'll see that's going to end up looking quite a bit different than a lot of the classic protest coordination games. But we think it's sort of a nice way to capture the dynamics that we want to get at here. I'll just quickly say there's like a couple other papers that also talk about this trade-off in a formal fashion. But I think the sort of the advantage of what we're doing over those papers is they just kind of do a very reduced form approach of saying like, well, better technology is going to lower the cost of mobilization, but also lower the cost of repression. Whereas we're actually going to model the information flows and actually how the citizens are exchanging information, and we're actually going to model how the government is trying to intercept information in a way that seems consistent with what we've observed in a lot of these recent protests. And I think in doing so, I think we're going to get some other extra insights along the way. Right. So in a sense, there's kind of like a basic science-y component to this paper where this is sort of a dynamic that people have been talking about a lot for the past 20 years. And I don't think there's actually any models that capture it in a particularly satisfying fashion, where we want to have both this, we say blotto-like features and these coordination features. So then we're going to get a pretty intuitive result out of this. So first, we're going to just show that, kind of just for checking as a sanity check, that this, again, captures some natural trade-offs, where what we're going to find is that in this environment, it's really only relatively private communication which is going to fundamentally change protest dynamics. So public information, maybe has some value for unmodeled reasons, but really you need information that you can get to other protesters, but which is not going to be observed by the government in order for the technology to truly help these movements succeed. Right. So again, this is like an idea which is out there a lot, but I don't think really formalized in a satisfying fashion. And then once we have done that, I think we're going to get some more subtle insights into some questions about like what technologies get used over time and why it always seems to be that there's relatively new technologies which are used to organize protests. And then also to get at some kind of more specific protest tactics, which we saw in both Sudan and Hong Kong, where there's often what we'll call parallel protests, which are happening at different places, but at the same time. And so the model is going to give us a couple ways to think about why that might arise, and at what stages in protest movements that tactic might arise.
Can I ask a question here?
Sure.
Because you had a contribution slide on, so I'll take advantage of that. So
sure.
You didn't mention the size of the protesting group. It seems like, whether this is 2 people trying to coordinate or 1 million people trying to coordinate would play a role here.
Yeah, so so we are, this is a good segue in the baseline model, we're going to start with a case of just 2 protesters. Towards the end of the talk, I'm gonna talk about what might happen as things get larger, and that's actually going to be a driving force of some of this parallel protest dynamic. That there might be some groups of protesters who can communicate more easily, and then others who are kind of more outsiders who is harder to get information to. So I think, yeah, we're going to at least like informally gesture at some of those dynamics. But again, good segue. We're going to start by thinking about a case where we only have 2 protesters, and they're interacting with a government G. So protesters are going to be 1 and 2, government G. The protesters' key choice is that they are going to decide among some set of sites. So you can think of site 0, meaning that they stay home. And then sites 1 through N are sort of potential places where they can go and stage a protest. So maybe a main square, maybe just a busy intersection. You think a lot about in different contexts, different places might make more sense as a place to protest. And so we're going to let capital SJ count the number of protesters who go to site J. The government's key choice is that they're going to have a set of resources R, so think of this as their budget, which they can allocate across sites. Easiest way to think of this is just like, the number of police officers that they send to each site. You could also think about tanks. You could also think about other kinds of resources they might use as well. All 3 of these choices are going to be simultaneous after a communication phase, which I'll elaborate on in a bit. And across all different variants, we're just going to use focus on SP&E. And like with a lot of coordination games, there's going to be a lot of different equilibria. So we're typically going to focus on the equilibrium which is best from the perspective of the protesters, and which we'll see. There's not going to be a conflict of interest between them. Okay, so the key technical object, which is going to capture most of our key assumptions, is going to be what we call the value of protest at site J. So VJ, SJ, RJ. So we're going to assume that this value is going to be weekly increasing in the number of protesters who show up. For the purposes of the presentation, I'm going to make a stark assumption that there's also going to be some very strong strategic complementarities in the sense that there's going to be no value if only 1 protester shows up at a site. So again, just to like make things simple, we're going to assume that both protesters need to show up at the same site in order for it to be successful. So you can think of that as like they need a big crowd to get attention, or that they need a big crowd to protect themselves from just getting immediately arrested and thrown in jail. And we can talk about what happens if we loosen that later. The next key assumptions are that the value of protest is going to be decreasing continuous and convex in the resources sent there. So this is basically going to primarily have a technical feature that it's going to lead the government to use a pure strategy rather than mixing. So if there was like increasing returns, they might like use a mixed strategy as well. This is going to make the model quite a bit simpler, in that it's going to lead the government to kind of spread their resources out because there's diminishing returns. Also, probably a pretty reasonable assumption that, sending a handful of police officers probably is going to have some impact. At a certain point, if you already have 1,000 police officers at a site, adding another one is probably not going to matter a whole lot. And so then finally, the third key assumption is that we are going to order the sites in the sense that ones with lower indices are kind of better places for protest. And so that could be because they're more accessible. That could be because of some symbolic value, because historically there have been protests at this site. It's just like a place that people know if a lot of people show up there, then the government's in trouble. Okay. So, we're going to lump all those reasons together and just assume that protest is more effective at the lower numbered sites. And just to simplify things a little bit, we'll assume that that's true in kind of sort of for any fixed resource allocation. So again, imagine like for any fixed resource allocation across the sites, 1 is the best, followed by 2 all the way down to N. The protester utility, so they're going to get a utility which on the first term here, you can think of this as like the sum success of the movement. So just summing up across all the sites, what was the value of protest at that site? Not super interesting in the case where like only one site can have value, but in some later extensions, there could be multiple sites that contribute to this value of protest, or like the sum value of protest. And then we're also in some things we'll get to later, allow protesters to pay a cost KI in order to participate, in order to not stay home. But just to keep things streamlined on our key results, I'm going to set that equal to 0 for now. So we're just going to be thinking about the choice of where to protest and not think yet about the decision of whether to participate in the first place. The government utility is essentially just the negative of the protester utility. So the government just does not want the movement to succeed. The government could potentially like value some sites relatively more than the protesters. These LJ terms can capture that, but that's not going to play a key role in our analysis. It's just possibly worth noting that this isn't necessarily a zero-sum game. There may be sort of some sites that like the protesters really like attacking, but the government doesn't care as much. But again, that's not going to be super important for our purposes. Okay, so the communication phase, how that's going to play out is one of the protesters, so arbitrarily protester 1, is going to get to send a message M from sort of an arbitrary message space. And then that is going to be observed by protester 2 with probability O. So think of that as like the other protester probability. And then it's going to be observed by the government with probability L. And so I love the picture that you all put together for this paper. I think we can illustrate the model using this poster. So if you imagine this I here is the government, maybe this is protester 1, the one who communicates with the phones. This is protester 2. So you can think of like L as the probability that that the I is going to see the message, and maybe O is the probability that we get this horizontal communication among the protesters. Okay, so I'm primarily just going to walk through 3, we can think of as corner cases, and then we'll think about the hybrid case once we build up our intuitions from the corner cases, where the first corner case is going to be one with no communication. So if O is equal to L is equal to 0, the message is just, one can send a message, but it just gets off into the ether, no one observes it. Then we're going to think about the pure private communication case. So this is where the protester is definitely going to observe the message while the government is not. And then we're going to think about a pure public communication case where the message is observed by both.
Andrew, can I ask a question?
Sure.
I think I know the answer, but just to make sure. These are assumptions, they're not equilibria, right? You're not looking at equilibria where there is no communication, for example, but you allow it in principle. You're restricting communication cannot occur in the first example for yeah
that's right. So think of it as like public communication technology or private communication technology. It's not a state that happens in equilibrium.
Yeah, okay.
Actually, that's a good terminology clarification. Okay, so let's suppose that the citizens cannot communicate with each other. So that doesn't necessarily mean that they're not going to be able to show up at the same site. So this, will not surprise theorists. We talk a lot about focal points. You can find lots of wonderful quotes about this in the literatures on various protests. One that I like quite a bit from an older protest. I was talking about protests in Leipzig and saying that, everyone just knew that when you wanted to protest, well, the Karl Marx plots, that's where you go to protest. And not only that, but people knew that, Monday between 5 and 6, after the peace services or after Monday prayers, that was sort of where the protests would happen, right? So if there's just this kind of tacit knowledge among protesters that, that's where protests happen, then they can go to the same site in the same place, even absent any explicit communication. Right. So formally, I'm not even going to show you any math here because this is quite straightforward, that there's always going to be, for any site J, there's an equilibrium where both go to site J and the government sends all their resources to site J. Right. So clearly protesters don't want to deviate because they both need to go to the same place for the protest to work. Government, knowing that for the government to be best responding, they have to send all the resources to the same place. Right. And so of course, among this set of equilibria by our assumptions, the best one is going to be the one where they where everyone goes to site one, because that's sort of the best site for protesters. So we'll often call it the focal site. However, it is possible that the citizens could play a mixed strategy here, right? So if you think of it as the citizens want to reduce the amount of repression they face, well, if they were to play a mixed strategy and go to different sites, then the government is also as well going to have to spread their resources out to account for the fact that protesters might show up at different sites. So there's sort of a benefit of this mixing. However, there's also going to be a cost, which is that since the citizens aren't able to communicate with each other, they're sometimes or maybe often going to miscoordinate. They're going to go to different sites if they play a mixed strategy. And that they can't correlate their mixed strategies, then they're often going to miss each other. And by our assumptions, that's going to be very bad because there's no value to these protests where only one shows up. Right. And so the key technical result here, the proof is quite straightforward. I can show if people are curious, is that under the assumptions we've made, in fact, this mixing is not worth it. So it's best for the citizens to always go to site one. So intuitively, this is driven by two things. So first, it's certainly driven by this strong strategic complementarity, the fact that they both need to go to the same site. So for example, if like the value of protest was just additive and, the value of 2 going to a site was just twice the value of 1 going to a site, then the citizens would definitely want to play a mixed strategy. Because if it sort of doesn't matter whether or not they show up at the same site, then really what they want to do is just sort of like maximize the confusion for the government, and they would want to play sort of a wide mixed strategy. Right. So the strategic complementarity is very important. And then also this also follows from the convexity of VJ. So the fact that there's diminishing returns loosely means that like if the citizens were to play a mixed strategy where they say go to site 1 half the time and site 2 half the time, and the government splits the resources 50-50. So since the value of protest in terms of like the probability scales linearly in that probability. Right. So, if there's only a 50% chance we go to the same site, that's going to shrink the success of protests by 50%. But if we shrink the resources by 50% by the convexity, that it doesn't, there's not going to be more than 50% benefit to doing it. So this is just sort of the combination of convexity and the strategic complementarity, best off just going to the focal site. Okay, so now let's talk through the private communication case. So here's just an example from Sudan talking about, a way to create this private communication by setting up these private WhatsApp groups where people were pretty confident that anyone who was in the group was another protest leader or at least participant and not a spy. And so then, they could tell each other what site to go to, all show up at the same site, and presumably not have the government catch them. So the way to think about this formally is that now one gets to send a message M, and the protesters can now condition their behavior on the message which is observed while the government can't. So the government's going to have to just pick a resource allocation while the citizens can just sort of always show up at the same site. Like in any coordination game, there's still going to be a lot of equilibria. We're going to focus on a natural class of equilibria, which we call ones in direct messaging, which just means that once the message M is sent, both protester 1 and 2 are both going to go to that site. And so it's sort of easy to see that in fact, any optimal an equilibrium of this form is always the best that the citizens can do. Obviously, they could like do other things where, you send M and they go to M+1 or they go to M-1. But in terms of the eventual payoffs, this is the best that the citizens can do. And so essentially now we're kind of just like treating them as a unitary actor because of this direct messaging assumption, which again is kind of innocuous here. It's the best they can do. And once you make this assumption, this essentially just turns into the model studied in Bob Powell's 2007 APSR paper, which is like a wonderful paper that everyone should go read. But I'll just walk you through the key steps of what the equilibrium to this game looks like. So first, consider the case where the government has very few resources. And so if the government has very few resources, then since site 1 is the most intrinsically valuable, then even if the government were to send all their resources to site 1, it'd be better to go to site 1 than site 2. right? So certainly in the limit as R goes to 0, this is you know, by assumption, this is obviously going to be true, right? So think about the level of resources, call this R hat 1, such that if the government sends all their resources to site 1, the protesters would be indifferent between going to site 1 and an undefended site 2. So if R is less than this threshold, then we're just all going to go to the focal site. You know, the protesters can communicate, but there's kind of no reason to, because they'd rather just flood the focal site. But then, so think about what happens as R gets slightly bigger than this threshold. So now, hopefully you can see intuitively what's going to happen is the government is going to start sending a little bit of resources to site 2 to make the protesters indifferent between 1 and 2. And since site 3 is worse than site 2, the protesters are going to not start going to site 3 yet. So there's going to be some range of resources where the protesters go to sites 1 and 2. The government sets the resources to make them indifferent between those 2 sites. And so this argument is just going to iterate up that, so if you want an equilibrium where n sites are protested, what do you need? Well, you need the citizens to be indifferent between those n sites, given the resource allocation. And then you do weakly prefer going to any of those sites to going to site n+1 if it's totally undefended.
Again, just a clarification. By going to 1 and 2, you mean that they mix between going to 1 and 2. In realization, they either go to 1 or 2, right?
Yes, and so yes, so thanks. Yeah, so the mixing is only going to be in the message sent. So they play a pure strategy conditional on the message sent because they always go to that. But there's going to be mixing in terms of what message is sent. Yeah, right. But so yes, they're always going to go to the same site in equilibrium. Right. Again, that's like the key thing, which is communication doing here is it's essentially allowing them to correlate the site they go to. So rather than miscoordinating, they're always going to go to the same site. Right. That's like the value of protest in this model or communication in this model. Okay, so yeah, so this again, this is literally just the like proposition 1 from the Powell paper, that what happens is as the number of resources increases, we're going to get more and more sites protested and defended. And so the government's always going to have to make the resource allocation to make the citizens indifferent. Then the last thing you need to figure out is what the actual mixing probabilities are. It's a pretty straightforward calculation. Broadly speaking, you just need to find a probability of going to each site that makes the government indifferent between a marginal increase in the resources at any site. And it's a quick calculation. You can see there's a unique solution to that problem. It's like a basic Lagrangian optimization problem. Again, I'm happy to show you that if you'd like, but it's not going to play a key role moving forward. Okay, so that's the private information case. So now let's think about public communication. And so let's like focus on the case where R is bigger than what I just called R hat 1, because again, otherwise just everyone going to the focal site is the best thing to do anyways. And so there's no value to communication anyways. So I think it's useful to do kind of like an off equilibrium conjecture, which is to say, okay, well, the citizens could play the mixed strategy that we just characterized, and one can send different messages and they can go to whatever site that one sends. The problem now is that since the government is going to observe M as well, they're just going to send all of their resources to whatever site corresponds to the message, right? They're going to see the protest poster, know that the citizens are going to, the Karl Marx plots at 5 p.m. to mix examples, and they're just going to send all of their forces there as well. Right. And so, in fact, this is not an equilibrium, or at least so once we assume direct messaging, there's in fact going to be a unique equilibrium where the protesters are just always going to go to the focal site, right? Because it's like the government is gonna go there no matter what, so we might as well just go to the site, which is best. And so, interestingly, notice we've like gone back to the no communication case in terms of what's best for the protesters. So in a sense, non-monotonicity isn't the right way to put it because we're working in 2 dimensions here, but it's like really only private information which changes the dynamic when you sort of have private and public communication together, or sort of if you have both the government and the protesters seeing the message, we go back to the case where no one observes it in the first place. Right. So that's sort of the key intuitions for the 3 corner cases. So if there are any questions, this would be a good place to throw them in. Okay, so now that we've worked through those intuitions, I'll just kind of start waving my hands a little bit more to give you a sense of what the model looks like for these intermediate cases. So remember now, so O is going to correspond to the probability that the other protester observes the message, and L is going to correspond to the probability that the government observes it. So actually, one thing that we're still finalizing the proof for is that the best equilibrium for the protesters has to have the form that if the other protester does not observe the message, they just go to the focal site. They just go to site 1. So in other words, we're going to have quasi-direct messaging where, the protester 1 may play a mixed strategy and suggest different sites. But if the message doesn't go through, 2 is going to say, okay, well, my best guess is I'm just going to go to the focal site. So we're still in the process of proving this, but we're fairly confident this is the optimal equilibrium for protesters.
Can I ask, because this is obvious, you're assuming that the sender does not observe whether the receiver actually got the message.
Yes, exactly. Yes, so if it was the case that the sender knew whether or not the receiver got the message, then things would look different.
Okay.
In fact, actually, that would be better for protesters in the sense that if it was common knowledge that the message was missed, then they could just always go back to the focal site.
Yeah.
Yeah.
And the same thing.
So we kind of want there to be some miscoordination. And I think also realistically, a lot of times they don't know if the message got through. So yeah, thanks.
The same thing for the government, right? So the sender knows whether the government does not know whether the government has observed or not.
Yeah, that's right. Thanks. Yeah. And so what the government does here is relatively obvious. If they observe the message, they're going to send all their resources to that site. And if not, then they are going to, pick some other allocation, right? They're going to potentially spread the resources across multiple sites when they don't intercept the message. And so hopefully you can see intuitively that in order for the citizens to get away from not being able to do better than all going to the focal site, we're going to kind of need O to be high relative to L. Right, because again, in order for the protesters to be able to sort of hit some of these other more minor sites, they're going to need the message to get through that's the site that we're going to, and they're not going to want the government to observe that, so they can send all their resources. Right, and so there's sort of a lot of intermediate steps, but the loose intuition, which again I think just captures kind of the folk wisdom about this, is that the value of a technology is going to be weakly increasing in how good it is at getting to the other protester, weakly decreasing in the probability of leaking. So I will just walk you through one calculation, which I think is helpful for understanding how this works, which is just to define the boundary, which says when a technology is useful in the sense that it can make the citizens better off than they would be if they all just go to the focal site. So in other words, we want to sort of define the exact boundary where there's a deviation where if the government would send no resources to site 2, if they don't intercept the message, the protesters would rather try and surprise the government by going to site 2. I sort of put undefended in quotation marks because it will be defended if the message leaks. But if it's undefended without leaking, when would the citizens rather switch to start protesting site 2? Okay. So remember, their value of going to site 1, if all the resources go there, is just always going to be V1 to R. And so what happens if you kind of, again, potentially surprise the government by going to site 2? Well, if the message isn't observed by the other protester, then the value is going to be 0 because they're going to miscoordinate. If one says, hey, no, let's go to 2, but the other protester doesn't see it, they're both going to get value 0. And then if it is observed by protester 2, well, then what's the utility is going to depend on whether the message leaks as well. So if the message does not leak, then this is like the good scenario, right? This is where they hit the government unsurprised. They didn't expect site 2. But if the message leaks, then the government's going to send all their resources to site 2, and they actually would have been better off just going to site 1 because it's more intrinsically valuable. Okay. And so this is sort of that indifference condition. So this is the point where the citizens are indifferent between, going to the obvious site and trying to surprise the government at site 2. And so if you just rearrange this and solve it for O, this is going to give you the critical value of the other protester observing the message, which is required for it to be valuable in the sense of, again, making this communication better than always going to the focal site. So here's what that looks like for some parameters. So on the x-axis here, we have the probability of leaking. On the y-axis, we have the probability of observation. So this, unsurprisingly, this frontier is increasing. Focus on the black line first. So if a technology leaks more often, it's going to need to get through to the other protester more often in order to be of any use to the protesters, right? So you can think that like, up here, these are going to be really valuable technologies, right? This is like the pure private communication case. And then notice it's not a coincidence that this is here the no communication case and the public communication case, and both of these are like below the usefulness frontier, right? So if you sort of are like near no communication or near public communication, there's not going to be any value to the technology. We sort of need to be above this curve. The second thing to notice from this picture is that when the government resources are higher, that's going to bend this curve down. And so the reason why this is true is, remember, when the government has very few resources, there's like no reason to try and do anything complicated. We can just all go to the most valuable site, and there's no reason to try and like do anything fancy and try and confuse them. It's better to just go to the focal site. So as the government is more repressive, as the government has more resources, there's sort of more value to trying to mix things up and try and find a way to get to a site undefended, even if it might lead to miscoordination and it might get leak and you get repressed at the other site as well. So in other words, there's a sense in which this communication technology is like more valuable and more important in the presence of a repressive government, at least for solving this problem. Okay, so that's sort of the key findings of the like baseline two citizen no protest cost model. So again, I think it sort of creates some nice intuitions. Nothing super surprising yet. I view this as like codifying things that people are saying in a model which seems to get at some realistic dynamics. So now let's start to add some things to the model and potentially get some new insights that are maybe not quite as obvious. So this one actually maybe doesn't meet that. This one is kind of obvious, but is useful for some of the later extensions. Is suppose that now there's a cost to protest. So before we just assumed there's no cost, so citizens or protesters might as well just decide which site to go to. So let's just like starting with the no or public communication case. Well, what do we need to get both citizens to not stay home? Well, we just sort of need, the value of going to the focal site, knowing the government is going to repress it as well, has to be higher than the cost for both citizens, right? Otherwise, they're both going to stay home because we need both of them in order for the protest to succeed, right? And so then you can think about the private case as well. If conditional on both protesters participating, they're going to have a more successful protest, right? Because they're going to be able to get the government to spread their resources thin. And so there's a sense in which this private communication might actually facilitate protests that wouldn't happen otherwise, because if one of the citizens would find it too costly to go to site one, knowing the government's going to be there, then maybe by getting the government to not send all the resources to one site, we can induce more participation. So there's a sense in which this better communication can make protests happen that wouldn't happen otherwise, right? Because we sort of need both of them to be willing to protest. Another kind of maybe here's our first like non-obvious result is so now remember in the baseline model where there was no cost to protest, as the government resources went up, all that happened is the citizens just protested more sites, right? They just like spread their protesting activity more and more across the different sites. Though in fact, that actually isn't a sign that they're succeeding, because they sort of need to do that because the government has so many resources that they can really fortify the key sites. So they sort of have to protest at these minor locations, which are maybe not as good. So if you add this cost of protest, you actually now get this interesting non-monotonicity, where as the resources go up, eventually we're going to get to the point where it's no longer worth it for the citizens to protest at all. So if you like look at the number of sites protested as a function of the government resources, it's going to be increasing for a while, and then it's just going to jump off a cliff because now the movement just can't succeed at all. right? So I think another, like a useful way to think about this is like if the protesters are, you know, in a sense, doing a good job of protesting at lots of different sites, that's sort of like a good and a bad sign from the perspective of the movement, because ideally they'd be able to all just, you know, go to the same site and overwhelm the government. But it also means that they're sort of communicating well enough that they're not just staying home because they can't do anything. So sort of interesting trade-off there. Okay, next extension is a famous idea that you could cite a lot of people here, but the sort of famous sociologist Douglas McAdam talked about how there's this often cat and mouse game between the protesters and the government, where they're always sort of coming up with new tactics, new technologies to try and organize their protests until the government catches up in some sense. And so the model, we think, provides a nice explanation of this dynamic. So if you have a dynamic model, where I'm using scare quotes because you know, there's like nothing deeply dynamic here. We're just imagining this game happens in discrete time periods. You know, no, like the choice you make in one period affects the future. But what's going to change over time is just exogenously suppose these O and L parameters change over time, right? We might think that they're like both increasing over time as a new technology becomes more widely adopted, right? So, you know, at first no one's on Twitter, and then it explodes, and then the police can monitor it very easily. So we can then ask the question, like, when is a technology going to be useful for the protesters if it's just going to be increasing in both O and L over time? And so it's like quite easy to see, if you just look at this picture here, that if we imagine any technology starts down in this corner where no one's aware of it, and at least I think for some technologies we might eventually end up in this corner where everyone knows the technology. And so notice it's like certainly not going to be useful at the beginning, and it's not going to be useful at the end of that process. And so if it like traces a path something like this, then it's never going to be useful, right? We can sort of never cross this usefulness frontier. But sort of relatively generically, if a technology is sort of like better and maybe gets observed, is sort of very good initially and is highly observed by the other protesters and not the government, then we're going to sort of cross the usefulness frontier, but then potentially cross it again. So in a sense, these technologies are only going to be valuable for some intermediate phase where O is high relative to L. And so what we might see over the course of a movement, or we might see as we look at like different protest movements across time, is if you imagine like here's sort of like an earlier adopted technology. And so this red curve is O, the blue curve is L. And so here for this one, it's like only useful for periods 4 to 6, when there's relatively a big gap between what the other protester sees and what the government sees. Then here we've got like a later starting technology, which is just shifted over. And here, this one is useful from, say, period 7 to 9. So this is maybe why we're going to see this constant innovation where, you know, we're only going to see the technologies being used when we think other protesters are up on them, but before the police kind of catch on. So this, again, seems to apply not just to social media, but to a lot of different kinds of communication tactics used for protesters. How are we on time? Okay, great. Oh, perfect. So I think I'll probably end a little bit early. So let me just walk through 2 more extensions. Maybe actually getting back to Max's initial question is, so what happens if there's more than 2 protesters, right? So obviously a key dynamic here is the size of the movement, how many people are kind of activated, how many people can see messages. So we have one extension where we have an arbitrary number of protesters. And we, for simplicity, we partition them into, we call insiders and outsiders. So another way to think about how sort of good a technology is, or how well protesters are using a technology, is think of it as like, how many people can you send the message to before it's gonna, you know, leak and the government is gonna find out about it, right? So it's like, how many people can you invite into the network before the cost of leaking outweighs the benefit of sending it to more people? So a simple way to think about this is, imagine there's just like a number of like trusted insiders, and then everyone else is an outsider. If you send a message to them, you know it's going to leak to the government. Obviously, you could consider intermediate cases, but this is a helpful starting point. So we show that there can be an equilibrium, and no proofs here, but like it's potentially optimal for the citizens, where So what is going to happen is that the insiders are essentially going to send a message that says like, hey, here's where like the parallel protest is going to be. And then the outsiders are all going to go to the focal site. So you can think that there's like a bunch of people who don't really know, where the secret protest is, but they just go to the main site. But then other people are gonna protest at other sites as well in a way that's going to be unpredictable for the government. So the value of this tactic is that if the government may have to spread their resources away from the focal site. So we're going to take some resources away from the focal site because the government doesn't want the other sites to be totally undefended. And so in a sense, that's going to be like helpful for building the movement because you're lowering the degree of repression which these outsiders face if they go to the focal site. Right? So in a sense, we're like taking pressure off the potentially less committed outsiders who can just sort of know like, oh yeah, I can go to the focal site. It's not going to be totally overwhelmed with police because they also need to be dealing with the more committed people who are going to other sites. So there's like a lot of different steps you need to go through to verify that this can be an equilibrium, but we can sort of find some parameters where this works out. And so sort of intuitively now we're getting even more hand wavy. We can think of this as like a tactic which might be good at helping grow movements in the sense that you kind of want to make it easy for people to start going to the focal site in the sense that you don't want them to like have to go to the focal site with tons of police there. This way you can maybe get more and more insiders by, they start going to this focal site. There's not tons of cops there. Then they get connected to the network. Maybe they become insiders and then we can, they can start joining these parallel protests too. And then again, we have sort of some math behind this claim that if the movement sort of gets large enough, once you kind of get enough people involved in the movement, you can actually go back to just everyone going to the focal site because there's enough kind of active protesters that they can just overwhelm the government forces there. So a second dynamic, I think actually Tak-Huen is here now. So Tak-Huen thought that there was a slightly different thing going on in Hong Kong where they used this parallel protest tactic, which could be driven by the fact that citizens maybe have a heterogeneous cost of being repressed. So this could certainly come out of the fact that, say, if you're just like a 22-year-old student or you're unemployed, maybe you don't care a ton if you get thrown in jail for a few days. Whereas if you have a job that you might lose, then being at a protest where you get thrown in jail might be very costly. And so we have another extension where there's heterogeneous costs to going to sites where there's a lot of police presence, and you can actually get a parallel protest dynamic, which in some sense is the inversion of the previous one, where it's in fact the really committed people who go to the focal site, knowing that there's going to be a lot of police there. And then people who are a little less committed can kind of do like smaller neighborhood protests, which aren't like really splashy, which aren't necessarily going to make the movement succeed on their own, but they sort of know that most of the police are going to be at the focal site, and so they don't have to worry that they're going to get thrown in jail. Okay. So this is like another way that these parallel protests can help build the movement. And again, there's sort of another dynamic where these kind of like clever tactics may be most useful at intermediate stages, where there's sort of enough people involved that they can get some value of having multiple protests going on. But really, ultimately, in the end, they'd like to be able to just overwhelm the government at one site. Okay, so I think I will wrap up there. Okay, right on time. And so hopefully you've seen that this is a tractable model that we can use to study how both protesters and the government uses communication technology. We can model sort of private communication, public communication, semi-private communication. And then in addition to codifying a lot of conventional wisdom, I think we can observe a lot of dynamics which seem consistent with a lot of the motivating cases. So I will stop there and look forward to taking your questions.
Okay, thank you very much. There were some questions in the chat. Max, Arda, but anybody else, just unmute yourselves. Maybe raise your hand so I can see who's first, who's second. Otherwise, just unmute yourselves. Whichever is, it's not easy to coordinate, in other words.
Need better technology.
We need better technology.
Hopefully the government is not watching this.
I have a sort of more esoteric question, but does this allow for any kind of benefits of repression? So if we think of the case of Hong Kong, the yellow vests in France, repression kind of proves the point that the government is repressive. So you want a little bit of it.
That we do not have that dynamic here. Obviously that raises questions of like, why would the government do that if if it's just going to help the movement. But yeah, I mean, I think there's some other models that consider these kinds of dynamics. Other people might have the citation offhand where it's like the more you repress, that also like lowers the value of the status quo, and that can lead protesters to go out more. So short answer is we don't have that dynamic here, but I think that's sort of covered elsewhere, and hopefully someone else will remember the citation for that.
Right. Anybody else?
I mean, I think should I try and get the ones in the chat, or it looks like Nikita's left, unfortunately.
Okay, so I can see Max's one. Can I ask a question about, which I think has a bit of a flavor of Max's question, so maybe we're gonna put them together, which is, so in your model, the technology is fixed and has fixed parameters, but you could think of the real world, there are several technologies that you can use, and you pick whichever one is better. Now, it's clear that in principle, you might want to use the one that has private communication in principle. But I was wondering whether in a dynamic sense, you could mix between technologies. So maybe you put something out on Twitter, which is publicly observable, but there's an elite that knows that the messages on Twitter are just, a feint. Whereas it's whatever happens on WhatsApp, that's actually the relevant thing. And some people know this, some people don't know this, and so on. So this brings up, I don't know whether you observe that in the field. Maybe it's too sophisticated a tactic, I don't know, but it'd be interesting. It seems to me to at least be theoretically possible.
Yeah, I mean, so there's a easy question there and a hard question. So, I mean, the easy question is, if there's multiple technologies, then like, since there's always a multiplicity of equilibria here, you can kind of just like compute the value of using technology 1, compute the value of using technology 2, and use whichever is better. I mean, that it's like a little tedious, but that's not hard. But yeah, I mean, I think the more interesting question and more challenging is like, can you get this deceptive dynamic where there's sort of like blatant misdirection where protesters purposely say, hey, go to this site, and then there's some private communication that says go elsewhere. So I mean, we don't directly have that here. I think it would be tricky to come up with a way where that sort of where like that happens in equilibrium, right? Because it's like, if the government knows that's going on, then why would they follow the message? I don't know. I mean, there may be some kind of like.
No, but there is an asymmetry, because some technologies would be observable by the government and some would not. Whereas, let's say that all the technologies, let's simplify, are observable by the public. So then you could purposefully sometimes use something which is observable by the government just to throw them off. I mean, do you observe this in the real life situations you've looked at? Is this something that happens? Because
I have to defer to my co-authors on that if they want to chime in. But yeah, I don't know if they want to. Oh yeah, hey, how's it going?
Thanks so much for that question. Yeah, I mean, what's interesting, I'm thinking about the Sudanese uprising, and it was really decentralized. And so there were instances in which that happened, in which there would be like, the more public organization that was happening, that was put out on Facebook or put out on the public WhatsApp groups or on Twitter. And then other people were like, okay, well, we know that the police are going to be there, so we're specifically going to go somewhere else. And in some cases, that was done with like the people who ended up engaging in this direction. Sometimes it was in coordination with the main protest leaders who were putting out the public messages, and other times it wasn't. So, but kind of coming back to the model, it definitely did happen, but it wasn't one of the main features that happened, at least in the Sudanese uprising. I think because I think one of the things that we're trying to capture in this model is that any tactic that's starting to work and is organized or formalized or set as the MO of what a protest movement is, it can't sustain itself. It has to update.
Okay, thank you. Max, did I do justice to your question, or do you want to ask it again? Anybody else? All right.
Just Max probably had to leave because he's got
Oh yeah, I forgot.
class.
Max had to leave. Yes, yes. So
let's see. I guess I can see if his question in the chat is.
I think it was similar to what I.
Yeah, similar idea. Yeah, maybe we should think about a way to get at this. I mean, it seems like for that kind of dynamic to work, I think it would have to sometimes be the case that the public message is used.
Correct.
Because if the public message is always nonsense, then why bother?
So, I mean, my only intuition here is that you're allowing for mixing on a given platform, and it seems to me where the observability is fixed from both your side and the other side, seems to me there's potential to exploit mixing between platforms, because there you have different observabilities. So that, for example, it would be, so if you can think about it, it's a signaling game, because by using the public one, you're taking a cost, which is that you are letting the government see what you're doing. And so, whereas everything seems to be cheap talk in your model up to now in some ways, right? So that would be something. I mean, as a theorist, that would be interesting in exploring. But then I asked the question, how relevant is it? Because might not be that relevant in terms of how it actually works.
Yeah. I mean, so this is yeah. I mean, I actually kind of, this is sort of like a different paper to write for me, in that we're having the constraint of not just going to the most theoretically elegant kind of answer, and I sort of always had the constraint of my co-authors who know more about this stuff, and so I probably asked May the question, does this actually seem right? 100 times over the course of this project, because again, that was kind of the point, is we wanted to model this technology as it was actually being used, rather than just what made the most sense theoretically. So that was kind of fun for me to have that different experience. But yeah, I mean so when you say it's signaling, so you think there's different costs to using different
well, I mean, if you send a public message, it's going to be observed. If you send a private message, it's not. So that suggests that there's a cost, right? Now, I would, to be honest, I haven't developed the intuition enough to tell you I think this might happen, but it seems to me that there's potential to exploit this in terms of playing not a pooling, not a separating, but a semi-separating equilibrium, where depending on parameter values, you sometimes might want, which would be the interesting thing, send public messages on purpose. Yeah, so that would be interesting from a theoretical perspective. I don't see a reason why not, none of us reason why not. But again, I completely agree with you. If this is not something that we observe in this particular application, then perhaps it's something, there are other situations where there's secrecy and somebody who might be monitoring, a bad agent who might be monitoring and so on, to which what I'm describing might apply, but not to these particular situations, I suppose.
And as always, you sort of, on the flip side, we don't want to just write a model which only applies to two cases. But it is, I mean, I do think it's a case where we started thinking about trying to write a good model for a couple of cases, and I think in the end, I think it does sort of travel a fair amount, I think, in terms of
I completely agree that this might be a next step, not something that you would want to do right now. I'm sorry, I've been hogging this entirely. if anybody has a question, there's always this tension between thinking there's nobody asking questions, so I'm gonna keep the thing going. I'm gonna ask one, and then people saying this guy is hogging the whole thing on the other hand. So if you can stay a few minutes more and somebody has a question, I'm happy to stay.
Sure. Yeah.
Anybody?